wrong thing. Here we go. No. Where's that? Well, I thought I just opened it. Let's try this all again. See, this is what I'm telling you. That's going to be on the video. They're terrible videos. All right. Okay. So, we are going to go over some stuff. This stuff that we're going to do today is just kind of get us broken a little bit. It's mostly Math 1 stuff that should be a review. There's a couple things that are new, but it should be a review. But I also realize that how it is at the beginning of a math class where you have forgotten a lot of things that you did once know. So this will hopefully get us started. So we're going to talk about functions a lot in this class. And functions are a special type of relation. A relation is the relationship between sets of values of ordered pairs. So an ordered pair is like we use for graphing on the coordinate plane. It could be like 2, 3, or 7, 5, or something like that. A function is an expression, rule, or law that defines a relationship between variables where, have I forgotten what even goes in the first blank? Some of these are word funny. I'm not starting off good today. Let's see. I think here I put each x has one y. There. So each x value, because if you guys remember, whenever you do those ordered pairs, your x comes first and your y comes second. Each x has only one y. The domain of a function is your possible x values. How many of you, did you guys all have Mr. Brown last year? He had all the 2. So you haven't, did some of you have Coach Wood and he's saying all my exes live in Texas on this? A few of you maybe, I don't know. If you heard Coach Wood singing all my exes live in Texas, he was doing domain because all your exes live in Texas, and Dallas is in Texas, and Dallas starts with a D, which is the same as domain, so that helps you remember that X is domain. So if you didn't get the pleasure of having Coach Wood, you've really missed out. So he's a crazy man. And then range is your possible Y values. All right. So where's my little thing that goes to the next? Oh, there it is. All right, let's clear this out. Okay. All right. So when you're looking at domain, it is your X values. So for this, these here are all X values. So if we want to write the domain for this, we're just going to list all of the X values. So for this, we would have -4, -3, 0, 1, and then 3. I almost said we don't do 3, but it's not in the list. So you wouldn't want to repeat any values, but none of these are repeated. Okay? And then the range is the Y value. So let me use a different color here. The range is just your Y values. So you're just going to list them 0, 1, -2, 2, 3. Okay? So there are several different ways how you can tell if something is a function or not. One of those, if it's listed out as points like we see here, one of those is that the x's do not repeat. You can't have an x that goes with more than one y. So you couldn't have 2, 1, and 2, 7. Right? So let's make ourselves a little note over here to the side. A function, the x's do not repeat. And so in this one, my x's don't repeat. I've got -4, -3, 0, 1, 3. They're all different numbers. So is this a function? Our answer for that would be yes. okay here? Good. All right. All right, so in Math 1, you learned about a vertical line test. We are going to add in a horizontal line test for Math 3 because there's one other thing that we need to know about functions. The vertical line test says that if a vertical line touches the graph of a relation only once at each point as it is passed through the graph, the relation is we're going to put function right here in this blank. So if you have a vertical line, vertical is up and down like this. If we have a vertical line and we go across the function, that line should only hit our function one time. And we're going to look at some examples here. You can also do a horizontal line test, which is the same thing. You're taking a horizontal line and you're seeing if it hits once or more than once everywhere. For the horizontal line test, if a horizontal line test touches the graph of a relation only once at that should say each, not teach, point as it is passed through the graph, the relation passes the horizontal line test. So you didn't really talk about that one in Math 1, I don't think. A relation that passes the vertical and horizontal line test is called a 1, 2, 1 function. Alright, so let's look at a few examples for this. Everybody got that down? Not too much to write on that one. Okay, so for these, we're supposed to determine if this is a one-to-one function, a function, one-to-one function, or not a function at all. Now, important to remember, all one-to-one functions are also just regular functions. And I gotta find my yardstick here. Okay, so if we are doing the vertical line test, which is much easier to do than the horizontal line test on the screen right here. Vertical line test, we're just taking this vertical line, we're going across that function, we're seeing if we hit more than once. Do we hit the function more than once here? We do, definitely, lots of places, right? So if that happens, if you hit more than once, vertical line test, then that's not a function. So not a function. And there's no need to check to see if it is a one-to-one function because it's not even a function at all, so it's definitely not a one-to-one function for that one. So that's what we've got on example 2. Now let's look at example 3. If I take my vertical line and I go across right here, do I hit more than once anywhere? No. This one passes the vertical line test. It only hits one time at every point on the graph. So this is definitely a function. What we need to know now is also a one-to-one function, right? So we're going to turn our ruler this way, and I'm not tall enough to do this well, but does it hit more than once on the horizontal line test? It does. So this is just a regular function. It's not a one-to-one function, just a regular function. In this case. Alright. Let's keep moving. So I want to get to my activity. Alright. Oh, that's not the next one. Come on. Okay, now, I'm just going to pull this up on my screen right now because I don't want us to get computers out for this one tiny little thing. But one of the good things about Math 3 is, although it does have an EOC, we get to use Desmos on the whole entire EOC. There is no calculator inactive section. There might be a few times that I don't let you use Desmos and just make you use the calculators just because I don't want the computers out. But for most things, you know, if Desmos is required, we'll have it out. If it's helpful, we'll have it out. So I'm going to pull up Desmos real quick. And everybody has used Desmos. Han, have you ever used Desmos here? Have you seen this? Maybe not. Right here. Okay. So Desmos, we just type it in y equals x to the second plus 2. Okay, so now we're going to vertical line test this one. Does this pass the vertical line test? Yes, so that means it is a function. So we have a function. Then we have to do a horizontal line test, and I'm really not tall enough to do it. Does it pass the horizontal line test? It does not, because it's going to cross more than once. Like if we think of drawing in a line right here, it's going to cross more than once. So this is just a regular function here. Let's see. All right, let's do our next one. We're going to do an exponential this time. 3 to the x power. Okay, now this one's a little tough on what it looks like. Okay, first of all, does it pass the vertical line test? We're good over here. Only hits once. Over here it gets really steep, and it's starting to look like maybe it's more than once. But remember that my ruler has some thickness to it. A line has no thickness at all. Like theoretically, the idea of a line, you can't even draw it because it has no thickness. So this is going to pass our vertical line test. This is a function. Now this one's a little bit tricky because is this one going to look like it passes that horizontal line test? It looks to me like it does not because it looks like it's just a straight line right here. But this is an exponential function. So look what happens if I zoom in right here. So right here, you can see we're decreasing. If I zoom in more, see how this kind of keeps moving a little bit? It's like, oh, it's going to touch. But does it touch? Oh, maybe over here it touches. Nope, still doesn't touch, right? So what's happening in that exponential is what we call a horizontal asymptote. It's getting closer and closer and closer and closer and closer and closer to that line, but it's not actually touching that line. So this one does pass both the vertical and the horizontal line test for that. So it's a little bit tricky because it doesn't quite look like it from far away, but if you zoom in, you can kind of see. So some of these, if I give them to you, I'll probably give them to you on Desmos, so you can kind of use that zoom to see if you think it actually does. So this one is a 1, 2, 1 function. Okay, got any questions so far? Okay. Let's keep moving. All right, so one thing we need to know a lot about is function notation. So function notation, you should have seen already some. It is the f of x notation. Everybody's seen that. Sometimes we would have equations that would say like y equals 2x plus 3, but then sometimes they wouldn't say y equals 2x plus 3. They'd say f parentheses x close parentheses equals 2x plus 3. Everybody has at least seen that before. So function notation, when you're doing math, is so helpful for a couple reasons. It allows for individual function names to avoid confusion as to which function is being examined. So a lot of times we might be looking at more than one. Like we might have a line and a quadratic or something that we're looking at. And if we call one of them F and one of them G, it makes it a little easier to talk about them. So we can give them different names. It also easily identifies the independent variable in a problem. So the independent variable is like what you're putting into the problem. Most of the time we see X there. It doesn't have to be. It could be a different letter. But whatever letter is right here, this is your independent variable. It's the variable that you're going to plug in. And then the part over here, the 3x plus 1, that's your expression. Okay, so we're going to use function notation more and more in this class. It's really helpful. I use it almost exclusively in my pre-calc and calculus classes. I rarely say like y equals 2x for that, because it really helps you when you need more than one here. And you'll see it a lot in the class. So let's, why are we not going to the next one? Come on, what's happening? We'll go back. Okay, there we go. I don't know what's going on there. Okay. All right, so to evaluate a function, so evaluating a function, you're going to plug the input for the, or plug in, I should say, the input for the function's independent variable, which is typically x, but not always x. And that just means that you're replacing the x with the number or the expression. So, I'm just starting off with a really basic example right here. It says, given the function f of x equals 3x minus 5, find f of 4. And that's how we read it. It looks like it's like f times 4 or something, but it's f of 4. It means plug 4 into this function. So when you see this right here, it means plug 4 in for the x. Right, so over here it was an x, now it's a 4. It's telling you to plug in 4 is all you're doing. So when we write this, a lot of times we might write f of 4 equals, because we're replacing that x with a 4. But this part right here is just a label. It lets us know in our work what we were finding. It's not, we're not going to do anything with it. It's not f times 4. It's just a label telling us we plugged 4 into this function. So we would have, I'm going to do this right here, like I'm going to make it like, I may be like way below what you really need me to do here, but sometimes I have students that this messes them up, so they need to do this, 3x minus 5. They need to go in, write it like it was, actually erase the x, and put the 4 where the x was. That's what you're doing. Everywhere there's an x, you're replacing it with a 4. I suggest parentheses. They're not always necessary, but a lot of times they're really helpful for that. So, I challenge you today to try to keep the lid on your calculator. If you get something that you can't do, you can take the lid off of the calculator, because we do get to use the calculator on our whole entire exam. But stuff like this, we really want to try our very best to do it like mental math, because you're so much faster than you are if you're typing that into the calculator once you get good at it. Plus, you don't get good at it if you always just type it into the calculator. So, especially low stakes sort of stuff where we're, no quiz, no test, this is just participation. Try your best to leave that lid on the calculator if you can. What do we do first here? Who can tell me what we do first? What do we do, Jonas? Good. And what will we get there? Good. And then we'll bring down that minus 5, and 12 minus 5 will give us, I think I heard it somewhere, 7 there. So 7 is our f of 4. That would be our answer for that. Do you guys remember doing this before? Seen it? Okay. All right. And some of you might be like, what class have I showed up in? This is too easy, Miss Hyatt. And some of you might be like, Miss Hyatt, I don't remember anything from that one. Why do you keep saying that? It gets harder than this if you are thinking it's too easy. Okay. All right, let's try. I'm going to do a couple more together, and then I'm going to let you try a few on your own, and then we got an activity that we're going to run out of time for probably. I always run out of time every day. So that's a trend. Okay. All right. So this is h of -3. So what we're going to do, I'm going to label it h of negative 3. But remember, this is just a label. It's not anything I'm actually doing with it, right? It's just reminding me I plugged in negative 3 into h. So everywhere there is a t, I'm replacing it with a negative 3. And I'm putting it in parentheses. That square still stays there. Minus 3 times that t is going to be a negative 3 right there, and then a plus 2. All right, let's try it without our calculators. What do I got to do first? Order of operations, PEMDAS. I need a square first. I would do parentheses, but I don't really have any. The ones I have here are just multiplication, right? There's nothing to do inside the parentheses. So exponents come next. I'm going to square that. What is negative 3 squared, Angel? Perfect. Positive 9, because negative 3 times negative 3 gives us a positive 9. All right. So 2 times 9. And then I'm going to go ahead and do this next step, because I can right here, because it's separated out. What if I have the negative 3 times the negative 3? That will also give me a plus 9. And then I got plus 2 right here. So now that I've done my exponents, what comes next? 2 times 9, perfect. That's going to give me 18 plus 9 plus 2. So 18 plus 9 is going to be 27 plus 2, and we will get 29 for that. Okay, let's do one that's a fraction here. I got h of, oh, that's a typo right there. That shouldn't say h. That should say g of 2. It's the second typo today on these notes. I need to go back and fix it, but I'll probably forget. All right, so I've got g of 2, and everywhere there's an x, I'm putting a 2. So I've got 1 plus, instead of that x right there, I put a 2, and then 4 times 2 minus 3. All right. What needs to be done first on this one? What? All right, kind of. Is there anything inside of the parentheses here? There's just a 2. Can we do anything with a 2? So, like, these parentheses aren't really parentheses here. They're just multiplication. However, there are, after parentheses, we got exponents. There are no exponents in this one, right? So then that takes us to multiplication. So that's what we're going to need to do first, right? So I need to do that 4 times 2. So I got 1 plus 2 over 4 times 2 will give us 8 minus 3. All right. And then what's going to come next? We're going to do that addition in the top. 1 plus 2 is 3. And even though there's not parentheses here, it's like there's parentheses around the top and the bottom in this case because it's written as a fraction. And so we could go ahead and do the bottom also. We get 8 minus 3, which is 5. And can we divide 3 by 5? We cannot. So I just leave it as a fraction. You are welcome to change it to a decimal if you would like, but I like fractions better, so you can just leave it like that. Now let me warn you on this. I hope my calculator works still this year. Oh, I think I had to use. Where was it? No, that's 89. No, that's not what I want. Oh, this is it. Okay. All right. So for the calculator, notice this one actually gives you problems if you try to type it in the calculator and you don't do it correctly. Like for this one, you got to be careful because if you do 1 plus 2 divided by 4 times 2 minus 3, it gave me negative 1. That's not the right answer. What did I do wrong when I typed that into the calculator? Yeah, it's got to be like in a fraction, and the calculator can't do it as a fraction unless you put parentheses around the top and parentheses around the bottom. So the solution is to either do it separately, like just do 1 plus 2 in the top and get your 3, and then do 4 times 2 plus or minus 3 like that. Oh, not like that. You know what to do there, though. Minus 3. Or you can do 1 plus 2 divided by, you got to do parentheses, 4 times 2 minus 3. Like that. You got to have all, that's a lot to type in at once. And it's going to give you 0.6. Do you guys know how to change it to a fraction on these calculators? It's not so critical because Desmos will also do it for us, but I'm going to teach you how, because sometimes I like to use the calculator. I like to use the calculators for like easy stuff, and then if I got a graph, I pull up Desmos. So if you want to change something to a fraction in the calculator, you're going to hit Math, and then Enter, and then Enter again, and that'll change to a fraction. So Math, Enter, Enter, and it'll change it to 3/5 for you if you want to use that calculator. Okay, questions? Okay. All right, we're going to do this last one right here, and then I'm going to get us started. I know we only got like 10 minutes, but I want you guys to get up and do something for a little bit today. So, and I know we got more in the notes. We might do a few of them tomorrow. We might not. A lot of times I'll put more than I need to put on the notes, and then I just skip a few of them if I've not got time. So like R of 5 here means that we're going to have square root of 5 minus 4 plus 2. Square roots don't have parentheses in them, but it's like you've got parentheses around what's in those. So that's what we want to do first. 5 minus 4 would just give me 1. So I've got the square root of 1 plus 2, especially since today I don't really want to get the computers out. You guys know how to type in the square root in the calculator if you need to. You're going to press the second button, the blue button, and right here above the x squared, you see that blue square root sign. That's how you get to it in this calculator. So square root of 1. What is square root of 1 before I hit enter? 1. It's just 1. 1 times 1 gives you 1, so that is the square root of 1. So this is just 1 plus 2, which is 3. Okay. We've got R of 20. They're asking us to do this again. So I've got square root of 20 minus 4 plus 2. Again, I'm going to do what's in that square root first because it's like there's parentheses around it. So 20 minus 4 is going to give me 16. And what's the square root of 16? It's 4. 4 times 4 equals 16. So 4 plus 2 will give us 6. This last one's weird. So I've got R of x squared plus 4. That means I'm replacing the p, in this case, with x squared plus 4. So x squared plus 4 minus 4 plus 2. So, like the last one, this has got like parentheses around what's here. So, if I've got x squared plus 4 minus 4, what's going to happen with the plus 4 minus 4? They cancel out. They're gone. So, really, this is just the switch back to blue. Square root of x squared, and this plus 2 is over here on the outside. What happens with square root of x squared? I think I heard it. Angel, do you know? Is that you mumbling? I think I heard somebody say just x. Squares and square roots are the inverses of each other. They undo each other, right? So if I have the square root of x squared, that undoes each other, and you just get x plus 2. But you can't really do anything else with that because it won't simplify any further, so that will be your answer. That's a little bit of a stretch, a little bit harder. You didn't do that in Math 1. That's Math 3 stuff that we'll see. Okay? All right. Okay, we only have 10 minutes. What I want you to do right now is I want you to get a sheet of paper, or is the back page of this blank? If you just want to flip it over and use the back page, you can also do that. So either on the back page of this, or if you want to use a piece of notebook paper if you like having lines. At the top of it, I want you to write 1.1 function answer hunt. Okay, and so this is what we're going to do. You are going to pick a question. Okay, so like I'm going to start right here on number 17. And I am going to work out number 17, whatever it is. Some of you might not need to show a lot of work, but at least put f of whatever and what it equals for that. And then whatever my answer to 17 is should be on one of these somewhere. So if it is, the answer is 6, which I don't know because I didn't work it out. If the answer is 6, I'll go to this next question right here. So that question is question number 13, which probably isn't right because I just didn't work it out. So then I'll go to 13 and I'll work that out. And then I'm going to find the answer to 13, and maybe it is 21. So I'll go over there where that answer is 21. And I can't see good enough to tell what that is, but 18, whatever. Whatever it is there, 18. And I'm going to work out that problem. And so what happens if you do this right, you're going to go in a circle. There's 24 questions, and you will end up back where you started. Obviously, we're not going to finish this today. We'll finish this at the beginning of class tomorrow. But I want us to just start to do a few problems before we leave, so you guys have some time. So everybody go to a different problem. Okay, you want to be at a different problem. And you are going to work that problem, then you find your answer and go to the next one. And then I'll just tell